Hi class. So this is the second unit. We'll just begin the first section of it today, and so what we're looking at here is units on radical functions, and today we'll look at radical functions and transformations. So let's start with um, a base radical function. Okay, so that would be just the square root of x. Okay, and so if we did a table of values, these are the values we get. So if we put some x is 0, 1, 4, 9. So notice what I've done here. I've used x values that are perfect squares. Then that'll give us the y values that you see that are the square roots. Okay, so as far as the domain and range goes, domain here would be x is greater than or equal to 0. And then the range y is greater than or equal to 0. So you can't have a negative square root, right? So that's why we don't have any negative values. Okay. Now, as far as the transformations that can be applied to it, it looks like this, where you've got the same letters A, B, H, and K, just like we did for Unit 1. So let's look at how we would go about graphing. Okay, so we want to sort of compare with that base function at the top there. Okay, so here you've got a equal to negative 2. Okay, you've got b equal to 1. We've got h equal to negative 3. So remember, it's the same as before, it's the opposite sign. And then you've got k equal to negative 1. Okay, so let's take the original coordinates we see at the top there, and we'll start doing the mapping. Okay, so we've got 0, 0, 1, 1, 4, 2, and 9, 3. So the first thing we can do here, remember, just like before, you save the translation to the last step. Okay, so the first thing we can do is we can incorporate that vertical stretch, which is a factor of negative 2, so it's going to involve a reflection as well. So what we're going to do here is we're going to change our y values by multiplying them by negative 2. Okay, so this one's still going to be 0, 0. We've got 1, negative 2. We've got 4, negative 4. And we've got 9, negative 6. Okay. Okay, so that takes care of that transformation. Now let's look at the translation. Okay, so we're going to go left 3 and we're going to go down 1. So we're going to take our x values and minus 3, and so let's just do that first. Okay, so x values minus 3, so that's going to give us negative 3, negative 2, 1, and 6. Okay, and then our we're going to down 1, so we're going to take away 1 from all our y values. That gives us negative 1, negative 3, negative 5, and negative 7. Okay, so now we've got, let's put this on the grid now. So we've got negative 3, negative 1, and we've got negative 2, negative 3, and we've got 1, negative 5, and we've got 6, negative 7. Okay, and there's your transformed function. Okay, the next one let's look at is where they give us the graph, and now what we want to do is try to figure out what the function equation is. Okay, and so what we can do here is we can uh, we can add in the base function. Okay, so just using the coordinates from the top there. So that was 0, 0, 1, 1, and 4, 2. Okay, so here's this is um, your base function. Okay, so this is your y equals root of x. So basically what we want to look at is what's happened here. And so if you look at this, the two are congruent. Okay, so again, congruent is a word I use when I'm basically saying that the two shapes and sizes are exactly the same. So what this tells you is you don't have any stretch that's been done to x or y. And then the second thing is because the orientation is the same way, you don't have any reflection. So all that's happening here is you're going up 2 and you're going to the right 1. Okay, and so what that tells you is your original function y equals root of x, this is going to now become y equals x minus 1. Okay, so that accounts for the going right 1, and then we're going up 2, so we can add a 2 to that. Okay, so again, what you notice here is that you're utilizing the same sort of structure of the transformation equation that we used in the previous unit. Okay, so I'll stop here, and now you can work on the questions that go with this.